Hello, everybody. My name is Calvin Remsburg. I am a network automation architect here at Juniper Networks. And it is a distinct honor that I have today to present to you one of the coolest innovations within the open source automation space, which is what we're calling JTAF, the Junos Terraform Automation Framework. Now, as excited as I am to talk about JTAF, we need to set the stage first and talk a little bit about what Terraform is, right? We need to set the context for those of us who don't live within the DevOps world and environment. So after our brief overview of Terraform, we're going to introduce JTAF and explain the role that it plays within an automation workflow. And then we'll wrap up with a couple of live demonstrations. We're going to start with something simple. We'll talk about building a configuration for an interface. And then we'll transition to something much cooler, a security-focused element of building a policy-based IPsec VPN in between two firewalls. And if you've ever built a VPN between two firewalls before, you'll know that there's well over 50 different elements that can be configured within these policies. So it's just a premier example of using automation for these types of use cases. All right, so going into a little bit about what Terraform is. Terraform is a vendor agnostic tool that's designed to help automate the deployment and lifecycle maintenance of our infrastructure. Now, Terraform is open source and it's maintained by Hashicorp, one of our fellow Security Field Day presenters this week. Terraform has been used predominantly within the cloud space, where its concept of state management and its adherence to multi-vendor and agnostic to any proprietary solutions has really made it one of the de facto tools within the infrastructure as code space. And within Terraform, there's this construct that we call a provider. And a provider, you can think of it like a plugin, and no one's going to yell at you for calling it a plugin. Because what it actually does is it allows you to interface with a remote systems API. So in the traditional cloud examples, that would be the AWS APIs or Microsoft Azure or VMware vCenter, right? The traditional infrastructure instantiation tools, those would be either the REST API or some kind of Python SDK underneath the sheets. In our case, within the networking space, we have NetConf. And so that's going to be a primary focus for JTAF in the conversation of what we're leveraging Terraform to provision on the Juniper devices. Now, Terraform itself uses a push-based model. If you're familiar with network automation, you'll know that there's two distinct camps within here. There's a push-based model where all the heavy lifting is done locally, in this case by Terraform, and it will push changes out to a remote device. In contrast, there's a pull-based model used by other popular tools like Chef and Puppet, where there's an agent that sits on the remote device and it does a little ET phone home and pulls down any kind of changes whenever they're needed. Push-based models like with Terraform and Ansible are definitely the way forward, especially for us networking engineers who well, let's be honest with this. We don't really feel comfortable running agents on our firewalls and on our platforms. So push models are a little bit more in line with what our expectations are for performing configuration changes. Now, on the technical side of things, for those that are interested, Terraform itself is a single binary that's compiled with Go. And that's a really unique distinction that's just worth calling out for a second, because a lot of the other automation tools that we see out there today are built on Python. And Python's great. I'm a big fan of Python. I think it's got tremendous use cases within the network and the network security space. But Terraform, being based on Go, has some additional capabilities that Go provides to us, specifically around performance, because Go is inherently asynchronous, and portability. Again, you can compile a single binary and you can ship it off anywhere. So you don't deal with a lot of the kind of headaches that you will with Python, with like virtual environments and having to declare your dependencies and all that jazz, right? So there is inherent benefits by Terraform using Golang. Now, you would never interface with the actual Go code itself. When you're consuming Terraform, the only thing that you actually interface with are configuration files that are either written in JSON or they're written in HCL, which is Hashicorp's language for Markdown. So now that we understand a little bit about the role that Terraform provides, right? We know that it's a network automation tool. Well, it's an infrastructure automation tool, and that there's this construct of plugins that we call providers. Now, from Juniper's perspective, when we decided that, yes, Terraform is definitely something that we want to help our customers use to automate the configurations on our devices, we felt like there were two different paths that we could have gone down. The first would have been to create a Terraform provider that spans all of Junos, because we run the same base operating system on firewall, switches, routers, MPLS, everywhere. We could have just created a Terraform provider and left it up to you, the consumers, to actually implement. But there's a lot of technical requirements and around being experts in either XML or in Yang data modeling, and we didn't want you to have to go down that route. Now, that this single provider is a very common path, and it's completely valid. You'll see other network vendors push the Terraform providers, and it's completely valid. However, we felt that we had a unique advantage in that the Junos operating system was built from ground up around automation through either the XML APIs or the netconf APIs or the Python SDKs that we expose. We felt like we had some distinct advantages that we should be taking care of. And so what we wanted to do instead is we wanted to enable customers to build a custom provider to specific use cases that they have. We'll talk a little bit about that right now. But this is effectively the path that we went down with Juniper, the Junos Terraform automation framework. So what is JTAF? Well, JTAF is an open source project that will enable you to build finely tailored providers for your specific environments. This dramatically reduces any kind of development time that's required for you to get off the ground and running with Terraform within your environment. It also reduces a lot of the skill requirements of either, again, becoming proficient in Yang, becoming proficient in XML, or becoming proficient in Go. We don't want you to have to go down that route. All the better if you can, but we want to help you get off the ground and running. And what's really great about the JTAF, again, is that wherever you operate Junos-based devices, whether it's in the campus switching, whether you're doing a cloud or service provider or data center or network security, we're running the same base operating system. So we have the same base APIs across the entire board. And as you know, again, with Juniper, it's built from automation. So you have 100% use case coverage for whatever type of task that you're trying to do on here. So you can effectively use JTAF for any environment that you're going to be working within. Now, of course, we like the network security space. And so we're going to be focusing in on a couple of use cases for network security, but don't think that it's limited to that. Again, the only limitation that you have here is your creativity and your business needs as far as what kind of jobs that you're trying to take care of. Now, what is it like when we're working with JTAF? Well, the workflow is quite simple. The very first thing that's going to happen is that you, the user, you're going to visit our public GitHub, and you're going to look through the list of version of software that we release, right? So we version control all of the Yang data models for all the specific platforms and all the specific releases that we have. You're going to download a Yang file from our GitHub that matches which configuration elements you would like to include within this custom provider. And then JTAF will analyze that Yang data model, and it'll come out with all the various types of configuration elements that you can perform. So it'll present you a list. And then the last thing from you to take care of is just select from that list. What are the things that you would like to configure? You'd like to configure IKE gateway proposals? Would you like to configure interface descriptions? Whatever it is, you just select from that list, and then JTAF will take your feedback and then compile the custom provider for you to insert within your Terraform playbooks. Now that now that you're done with the JTAF side of things, now you can start working with Terraform inside of your Junos environment. And the traditional workflow when you're operating inside of Terraform is 3 separate phases. There's an init phase or initialization phase, where Terraform is going to look for any of the providers that you're declaring in your configuration. Now, in this case, these will be the providers that JTAF has compiled for you. So checkbox, that part, the hard part's done. Terraform will also prepare a state backend to whatever your declaration is. In some cases, you're just going to be running it local. In some cases, you're going to be using like an S3 bucket in AWS so that everyone on your team can share the state. But the state is a really core component within Terraform and a key differentiation. And we want to make sure that we include that here with our providers that we're compiling for you. The second step within Terraform is the plan phase, where a plan will look at what your configuration says within your Terraform files, and it will compare that to the state. And then it will come back and say, all right, you want your config to look like this, but it currently looks like this. Here are the changes that we will execute when we go to the apply stage. And this is a great opportunity for you to bring in teammates, to do a peer review, to do an audit, maybe submit this to a change control within ServiceNow. Whatever your workflow is, this is a really great way of knowing with a high level of confidence, when we execute this, what's the end state actually going to look like? Now, when we've performed that peer review, when we feel like we're nice and comfortable with what the suggested changes are, then we move into the apply phase. And this is where Terraform is actually going to take all of your variables that you've established within your Hashicorp language code, and it's going to compile the actual configurations. It'll use the netconf API to interact with the devices to perform those changes, and then it will update the state within the backend so that Terraform understands that the desired configuration is currently the actual configuration on our devices. Now, before we jump into the live demonstration part, I want to just kind of paint the picture about what are some potential use cases here? Because this is really limited to the creativity of the administrator. So some really classic examples. Every single enterprise that I've worked in, every single security element and team that I've been a part of, we all have this construct of this idea around the golden configuration, right? And these might be elements that should be across our entire fleet of devices and should not change very often. Things like our SNMP config, maybe radius configuration, AAA authentication, syslog, right? These are elements that are necessary for the device's lifecycle maintenance, but they're often misconfigured, right? And so much to the chagrin of those of us in the operations team. So wouldn't it be great if you could build a custom plugin with JTAF that addresses all of those elements within the configuration that should be ubiquitous across your entire fleet? And then you can roll that out and ensure with highest level of confidence that every single device is running those perfect golden configuration elements within there. But don't just limit it to the entire fleet. You can also get down to platform specific. So in the case of firewalls, we're dealing with things like IPS policies. We have network address translation. We have security zones and security policies. We've got all these really cool things going on for us. So you could build a provider that addresses all of those things, unique either to the platform itself or the role that that device is playing within your environment. And in case, again, you could go into the campus where you might where you're dealing with things like power over Ethernet, where you're dealing with .1x profiles on all the access facing ports. In the service provider world, this could be things like routing policies, BGP autonomous system numbers, just really whatever the use case is for that specific platform or the role that it's providing. It's a really good use case for a Terraform custom plugin. Or if you get really creative with things, you could actually go into something that's more of a service delivery based, right? And so in the case of firewalls, think of it like the internet gateways from being provided from a virtual SRX within AWS or within Azure, or just building IPsec VPN tunnels, right? It's a painful job, right? Because there's so many elements that come into play here. There's security zones, security policies, address books, interface configurations, and just about a myriad of different types of options just for phase 1 and phase 2 within a tunnel. A really great way for a custom plugin. Or if you're getting into the IoT space, right? And you want to ensure that all of your network address, or I'm sorry, your NAC policies are consistent across the fleet. Again, a really great use case for that as well. So with that being said, I'm going to go ahead and transition now into our live demonstration. We've got a couple lined up here. We're going to start by using JTAF to build a Terraform provider that will enable us to provision interfaces on a SRX firewall. And then we'll move into a more security one where we're going to be doing a IPsec VPN between a couple of firewalls, again, using a custom Terraform provider for us. I'm using EveNG as my virtualization platform for today. And this is our effective topology that we've got listed here. Again, I've got 2 virtual SRX firewalls. They're connected to each other over a simple routed interface. And what we're going to be doing is we're going to be building a Terraform provider that will enable us to perform the configurations that we need. Now, before I begin, let me just make sure that I've got no smoke rolled up, or nothing rolled up my sleeves, no smoke and mirrors. I'm going to look at the configuration for my groups. And the reason why I'm doing this is that the way that Terraform can maintain state within configuration is by leveraging our configuration group policies. Based on configuration groups, which is what Terraform will use to actually provision our devices, we can ensure with the highest level of confidence that the state of every single element within there is maintained and unique. So with that being said, I've got no configuration groups, which will also mean that I've got no security associations for my phase 1 tunnel. And I've also got no security associations for phase 2. Not too big of a surprise. If phase 1 is not up, you're probably not going to have phase 2. And that's again, because we effectively have no configuration on these boxes for these constructs. So the very first step in working with JTAF, again, is to visit Juniper's public GitHub and to look through all the Yang data models based on the version of device that you have. Now, in my case, I like to live by the seat of my edge. So I run bleeding edge for everything in my lab environments. And then I get to select which of the platforms that I want to run. And in this case, with the SRX platforms, we're going to pick the Junos ES. And inside of here, you can see, again, everything inside of Juniper is built around automation. So we don't just provide the data models for the actual configuration, but also for every single command you could run on a device. Those are mapped out through RPCs. And in my case, I'm going to look into the configuration and go down to the security context. And this is the actual Yang data model that I will download into my environment. Now, I've actually already gone ahead and done this. So we're just going to go ahead and skip to it. This is Visual Studio Code. I'm going to be performing a lot of the demonstration from this tool. It's a fantastic product by Microsoft text editor that gives us a console as well as a text editor so that we can actually see the files. And here I can see the Yang data model that I was just talking about regarding, in our case, we're looking at building an interface provider. So in this case, we can see all the various options that are written in Yang. And by the way, if you're not comfortable with Yang, don't worry, you don't have to be. You just need to learn how to download the file. That's all. While what JTAF is going to do is it's going to ingest these files and it's going to look at all the various options that you can use to provision. So in my case, I'm going to say JTAF Yang, which is an alias I have for the JTAF provider. And I'm going to tell it, here's my config file. And I'm not going to look at the config file, but it's just basically saying, hey, look in this directory, look in that directory. And then whenever you build the provider, I want you to put them in this directory. Nothing really exciting for the purpose of the conversation. Now, when I hit enter, what Terraform, or what JTAF is going to do, again, it's analyzing all of our data models, and it's coming back and it's going to present us with a list of every single option that can be configured, in our case, underneath the interface stanza. And if you ever wondered how many things that can be configured on an SRX box underneath the interface stanza alone, you're about to find out. And spoiler alert, there's a lot. There's quite a bit. So in this case, we can see the outputted file for the interface configuration. And let's just scroll down to the bottom. And here we can see that the number of configuration elements that you can have on the interface side comes in at 12,289. And if you guess that, it's probably a good day to go buy a lottery ticket. Suffice to say, whatever your use case is, whatever you're trying to configure, if it's one of these 12,000 elements under the interfaces, or if it's a combination of other elements as well, you can accomplish this within your own Terraform provider. Now that I have that list, I just need to tell Terraform which of those elements I actually want to configure. In my case, I would say, hey, JTAF, I want to configure an interface's name. I want to be able to configure its description. I want to create a subinterface. And on that subinterface, I want to put an IPv4 address, right? So just really clear cut, just telling Terraform exactly what it is that you would like to use, or what you would like it to build. At that point, we ask JTAF again to actually compile our provider for us. And this is what will actually be ingested within our Terraform workflow. And you can see here in the files, anything that shows up as green or red here is a new file within our environment. We've created the new Terraform provider that allows us to perform interface configurations, including its name, description, and IP addresses. Now, I could upload this to GitHub and then add it to the Terraform registry, but I've already gone ahead and done that just to save us about 20 minutes of twiddling our thumbs. And so now I'm going to be using this Terraform provider that we just compiled in order to provision our SRX firewalls. Now, again, let's just check that firewall again. Let's just make sure that there's no interface loopback configuration. So I'm going to say show configuration interfaces. I'm going to display inheritance just in case there was something that came in from a group config, and I'm just going to have the output in the set format. So we can see right now on our virtual SRX firewall, we have 3 interfaces configured. We have gigabit 000, 001, and a management port for out-of-band management access, which is how I'm accessing the device. There's no loopback currently on this right now. What we're going to do is we're going to use this custom Terraform provider to provision that loopback, again, with a description, an IP address, and we want Terraform to ensure that it's on the device and it's active. So pulling back a little bit of what Terraform configuration files actually look like. This is the sole file that you would manage when you're managing your firewall as code. The first couple of lines is just me telling Terraform, hi Terraform, I want you to use this provider. And this would be the provider that JTAF has compiled for us. And we can version control those as well. And then I need to tell the Terraform provider just a little bit of information about my environment. I need to tell it which firewall I would like to configure. This could be stored as a variable. In this case, I'm storing it as a string, an IP address. It could be a host name, a CNAME, whatever makes the most sense for your environment. And then I need to tell it, hey, what port are you going to use? What's your username and password? Or if you're using private keys for authentication, where does that store as well? You can either declare that here in clear text and then have your cybersecurity team come after you, or you could store it as environmental variables, or you could use an external secrets management source like CyberArk or Hashicorp Vault. There's a lot of options that you can have around secrets management, but that's basically just giving Terraform enough instruction as to how to communicate with your firewall. Now, here comes the actual part where we're doing the configuration. When I import my interfaces module, I want to tell it some basic information. And I'm telling it right now, I want to configure an interface and I want that to be loopback 0. And I'm going to give it a description. I want to tell it that the description is we've provisioned this with Terraform. We're going to create a sub interface like we talked about and associate an IPv4 address to it. And that's it. That's all you need to know. You don't have to understand anything about the Junos CLI. We're managing our infrastructure here completely as code. This enables a whole subset of additional workflow benefits, like using GitHub and CI/CD pipelines and peer reviews and merge requests. There's all kinds of additional tangible benefits of when you manage your infrastructure as code, and Terraform is a great platform that enables us to do this. Now, the workflow, again, inside of Terraform is we need to do an initialization phase. So we're going to say Terraform init, and that's going to allow us to actually discover where our Terraform provider is, and then ingest it into our local directory. That's a one-time operation for us. Now I'm going to clear the screen and we'll do to the next step, which is the plan phase. So with Terraform, we're going to say Terraform plan, and Terraform again is going to compare what we have on inside of that configuration file that we just looked at, and what does Terraform think of the state on the device. And then Terraform is going to come back to you and say, here's all the things that we need to change in order to match your configuration. So in this case, we're creating loopback 0 with a sub interface of 0 with an IP address of this IP address. And we're also going to be adding a description. Now, we haven't actually made the change, but Terraform is kind enough to let us have a peer review to understand what would those proposed changes actually look like. To actually push this into production, we'll say Terraform apply. And again, they're going to give us the review process, and they're going to ask us, are these the droids you're looking for? In our case, we're going to say, yes, that is exactly what we want. And then Terraform will reach out to the remote firewall and perform all the necessary changes for us. Now, this is incredibly valuable because what we can do is I can just go ahead and clear my screen. I can run this over and over and over again. And I will get the Terraform to tell me, don't worry, the state of your configuration is exactly how you have it declared. And so there's no concerns about pushing unnecessary changes within the environment. Now, if we come back over to our firewall, I'm just going to hit the up arrow just for a second. And now we can see that loopback 0 has now been provisioned on the firewall. It's given a description of provisioned with Terraform, and we can see the IP address associated with that as well. Now, here's the really great thing about all of this. If I was to make just an incremental change, the only thing that Terraform would do it would analyze again what is different between the state of your config and your intended config within your config file, and that's the only thing that will get pushed into the environment. So in this case, I've got an IP address on our loopback of 10.123/32. Let's say that was going to change and to become 40 is a good number. Now, when I go through the plan process, let's go ahead and clear our screen. I'm going to say Terraform plan. And what I'm going to get back is I'm going to see that Terraform says, listen, we know that you want your IP address to be 10.124/32, but right now it's 10.123/32. So if we wanted to, we could actually make this small incremental change and all the other aspects of our configuration remain consistent. So that's a real, again, a key differentiator within Terraform, and the ability to manage state provides significant value here within our configuration. Now, I'm going to actually switch to a GUI to show a bigger use case here where we're provisioning a full subset of different aspects for building our site-to-site VPN. So what I'm going to do is I'm just going to go ahead and say Terraform destroy. And what this is going to do is, again, it's going to analyze our configuration file, and it's going to say, we will destroy these elements within your configuration. I know the word is a little worrisome, but it is effectively an accurate term. It is destroying that construct within the configuration. If we come back to the device again, hit the up arrow, we'll see that our loopback 0 is completely gone. So this is the declarative infrastructure as code constructs, right? That we're writing up a configuration file to say the config needs to look like this, and anything that deviates from this specific configuration aspect will be remediated. So in the additional use case here for the second part of our demonstration, I want to build an IPsec VPN in between the two firewalls that we have. And if you look at the configuration aspects that are required, we've got over 50 different things that need to be configured. In this case, IKE proposals, encryption algorithms, authentication methods, what Diffie-Hellman group we're going to be using, right? These are all aspects that are necessary in order to be successful in building this VPN tunnel in between the sites. Address books, security zones, security policies, all these goodies, right? The value here that we have is that when you boil down your configuration, you remove all the CLI semantics, you remove any kind of concerns around APIs and such, and you just boil down your configuration into key value pairs. This really enables additional teammates to help audit your firewall policy changes, to ensure, again, that your configurations are going to be pushed to the device with the exact intent that's declared within the configuration file. Now, coming back over, let's just check our firewall again. I'm going to clear the screen here, shell, and we're going to clear it, and then I'm going to exit. And we'll just look again at our configuration groups. We got nothing, right? And again, we have nothing, so we have no security, IKE security associations, or IPsec security associations. Phase 1 and phase 2 is down because phase 1 and phase 2 does not exist within the configuration. Now, you don't have to just consume Terraform from the command line interface. For those of us that live in this DevOps world, it's infinitely faster. But when you're bringing on new teammates that might not be comfortable with network automation, what we need to do is we need to embrace an environment that makes automation easy to consume and easy to support by everybody. So in this case, I'm going to be using an open source tool here that allows me to launch Terraform playbooks within my graphical user interface. And one of these that I've got a couple. There's our Loopback 0 example that we just ran through. But another one here is for policy-based IPsec VPNs. What's going to happen whenever we click this little rocket ship to run, it's going to go and grab our GitHub repository. It's going to look at all those all those configuration elements that we've declared within code, and then it's going to run them through our custom Terraform provider to build the IPsec VPN successfully between the two firewalls. I'm just going to click this run. And we still get the benefit of the two-stepped approach, right? Where we have a plan phase where we can see all of the changes that are being proposed. And we have the actual apply phase where we're actually going to be performing the configuration changes on the devices. Again, really, really beneficial for those of us that might be a little, the palms start to get a little sweaty when we start to think about issuing network automation on a production device. Having an authoritative source tell you exactly what's going to change and what's not going to change gives us a nice little warm comfort blanket so that we feel confident going into our change. In this case, I could review all those specific elements that are proposed. For my case, I'm just going to go ahead and click that apply button. So we're going ahead and we're issuing the changes right now on the device. This will build that IPsec VPN tunnel. It will also build things like security policies, address books. It will build all the different elements that are required to be successful. So 52 elements in all, according to Terraform, and issuing it even in 50 seconds is faster than I'll ever be. And I've become okay with that. The automation will always be faster, but more importantly, it will always be more consistent. So here we go. We've got the configuration being applied right now on the device. We see the final commit going in through on the firewall, and Terraform says that it was successful. If I jump back into my firewall, I'm not even going to look at the config just yet. Let's just see if we've got phase 1 of our IPsec. Yes, phase 1 to our IPsec remote firewall is up. This could be another physical firewall. This could be a virtual firewall. This could be the secure edge that we just showed within the SD cloud. You're not limited. Again, any kind of use case and functionality is inherent within here. The second aspect of this is validating the IPsec security associations as well. And now we see that we've got a bidirectional tunnel going to our remote firewall. And if we just take a peek at those configuration groups, what we can see is that I've got this one configuration group, and I can see all of the security configuration that was performed by Terraform, right? Again, taking the CLI semantics, taking the specific knowledge on how to operate a SRX firewall configuration policy. When we wrap it in as code, all of those aspects no longer matter. And we can, with the highest level of confidence, ensure that what we have declared within our configuration is exactly what will get pushed to the devices. So I just want to leave us with a little bit of information as to where to go from here. We have a network automation. I'm sorry, we have an aspect within our community that's finally tailored to around security automation. We call this the Security Automation Exchange. You can find this on our community pages right here, where we're highlighting different types of use cases for network automation within the security context. Now, we also have some for data center and campus as well, but hey, we're the cool kids. We focus on network security. So if you're ever curious about what kind of things can we do with network security, either from a configuration aspect or from an operational aspect, right? Getting additional insights from the logs. We talked earlier about the use case of identifying which user has been logged into different computers and from which environments, right? That's a perfect use case for automation. And that's absolutely something that can be done either on the SRX platform itself or talking directly to the SD cloud. So if you've ever interested in learning a little bit more about automation, whether it's Terraform, it's Ansible, or it's Python or something else, highly recommend checking out our community. We've got dedicated resources just for the security aspect of things.
For people that are not really comfortable with doing the automation stuff yet, can you integrate it with commit confirm so you don't cut your feet out from underneath yourself?
Yeah. Yes. Yeah. We could, right? But here's the thing, like within Terraform specifically. So yes, you can do commit confirmed within the Python SDK within Ansible, et cetera. And we could extend it here within Terraform as well. But Terraform inherently gives you a commit confirmed I'm sorry, you're talking about, I thought you meant show compare. Yes, so commit confirmed to actually roll back. Good feature request. I'll talk to the primary developer to see if we can't get that in there. I actually like that because
there is this odd moment when you applied the configuration. You see the 100 commands going down, and then you try to verify what you did earlier. Can I still access the box? And when there is a delay, it's in most cases that you get a bit, let's say, nervous, yeah? And
sure.
Yeah, so if you don't have this DevOps background, back in the days, old school style was roll back in 5, yeah? So that if you have done something super stupid, that it auto recovers from that. Yeah, yeah. I think the difference is with a lot of the DevOps orientated Terraform stuff. If they break in container or service, in most cases, you can destroy it, rebuild it. It's no worries. But if you destroy the networking path and you can no longer access the box, yeah, that is then a bit problematic. So keep your scripts straight that the out-of-band management is still working and you still can access the box somehow.
Yeah, all valid points, right? Talking just traditional operations workflows, right? That's always been one of the biggest selling factors within an operations team when they start using the Junos operating system, right? Is that holy rollback functionality, right? That commit confirm, the one that has saved many network engineers from having to update their LinkedIn profiles. So yes, that's a really interesting idea about trying to get this integrated within Terraform, but very good suggestion.
Where do you think this fits in choices between, we're running Ansible, we're running Python, and now this Terraform option? Are there use cases that you feel are better for one or the others?
Absolutely. The first thing is what makes the most sense within your organization and what is easier to support. I personally will always make the suggestion, stick with what is easiest to support amongst your team. If you have a team that is heavily invested within cloud and they want to align around a single tool for instantiating compute workloads and the public cloud providers are on-prem, and they just want to rally around one tool rather than dealing with multiple, Terraform is going to be probably a better suited for that. Again, Terraform provides some things for those aspects around state management that other platforms like Ansible cannot. However, if you are a traditional network engineer, traditional network security engineer, and this is your first foray into network automation, you're kind of dipping your toes into the water, Ansible is probably going to be the best bet. And in fact, I would suggest everyone evaluate Ansible first and figure out whether or not it fits the mold for what it is that you're trying to accomplish. And at that point, start deviating into either Nornir or in this case, Terraform. But one of the really big benefits with Ansible is that you can take the literal CLI set commands from a Junos box and just dump it into a playbook and have success with that. So if you're looking to get started with automation and you don't know about Python, you've never had any of this type of traditional coding background, Ansible is probably going to be the thing that gets you success first. But if you're, again, a really cloud heavy shop and the DevOps mentality is, hey, we're just going to use one tool for everything, then perhaps Terraform might be a better selection for your organization.